Welcome to English for Professional Mechanical Engineers. I'm glad to speak to you today about manufacturing processes. My name is Ziyao. In today's lesson, we are going to introduce the principle and application of microelectrical discharge machining. Manufacturing involves making products from raw materials by various processes, machinery, and operations. The process we choose is based on product design, mechanical properties of material, and the cost. Today we are going to introduce one technique, electrical discharge machining. Among manufacturing processes, it is non-traditional. Electrical discharge machining is abbreviated as EDM, and it has been developed since 1940s. Its principle is based on erosion of metals by spark discharges. Nowadays, EDM is also a computer numerical control CNC machine, and hence, high accuracy can be easily achieved by this technique. Micro-EDM is one of the techniques among EDM and specialized for micro-machining. The principle of EDM and micro-EDM is the same. However, the difference among them are electrode preparation plus energy and precision. Micro-EDM is a newly developed method to produce microparts in a range around 10 micrometers to 100 micrometers. Micro, meso, mechanical, and mental are mentioned when it comes to micromachining. Therefore, we call these four terms M4. In order to achieve micromachining, we will take the following factors into consideration. They are working accuracy, tolerance demanded, dimension accuracy, shape accuracy, surface accuracy, and finally, the manufacturing process chosen. The EDM system consists of electrode, workpiece, connected to a DC power supply and placed in a dielectric fluid. Electrode preparation plays an important part for EDM. It is not easy to produce a micro-scale electrode until wire electrode discharge grounding was invented by Professor Masuzawa in 1985. There is a gap between wire and electrode. Traveling wire is used as a tool to machine electrode. This method provides high accuracy and good repeatability with the error of less than 1 micrometer, and therefore it solves all the difficulties of the electrode preparation. This video indicates wire electrode discharge grounding technique. Can you observe the spark generated between wire and electrodes? The duration of each spark lasts for only a couple of microseconds. Can you imagine how many sparks are generated in 1 second? This electrode is one example machined by wire electrode discharge grounding technique. The material of electrode is tungsten carbide. This material possesses very high hardness and leads to low machinability. The radius of the tip is around 30 micrometers compared to the microbar at the bottom of this photo. It is not easy to achieve this scale for this material, but without causing any problem for wire electrode discharge groundings. This is another example. The material of electrode is tungsten, which has high melting point. This component can be used as electrode for micro-EDM technique or it can be used as a micro pin with diameter of 25 micrometer and length of 300 micrometers. During micro-EDM process, the workpiece is fixed at the holder. Generally speaking, the application of EDM is not constrained by the hardness and strength of the material to be machined. EDM may be used to machine any conductive material, but it is especially suitable for high hardness and high strength materials. A further advantage of EDM is that there is no direct contact between the electrode and the workpiece. Therefore, EDM is also called non-contact process. This slide gives a simple explanation of the erosion process due to a single EDM discharge. First, voltage is applied between the electrodes. The breakdown of the dielectric is initiated by moving the electrode towards the workpiece. This will increase the electric field in the gap until it reaches the necessary value for breakdown. The location of breakdown is generally between the closed point of the electrode and of the workpiece. When the breakdown occurs, the voltage falls and the current rises abruptly. The dielectric has been ionized and the plasma channel has been created between the electrodes. This video shows the process of micro-EDM. Due to the rapid heating and cooling effects induced by the machining process, a thermally affected layer will be formed on the surface of the component. Normally, this layer is called recast layer or white layer. These photos reveal distinctive morphology of a surface which has undergone micro-EDM machining. The enormous amount of heat are generated by the discharges. Melting and vaporization of the material are occurrent and is followed by rapid cooling. The surface profile reveals that the surface roughness is caused by an uneven fusing structures, shallow craters, pockmarks, voids, and cracks. The microstructure of this layer is quite different from the parent material. Although it is beneficial in terms of enhanced abrasion and erosion resistance, the defects within it, such as voids, crack, induced stressors, it causes an overall deterioration of the component's mechanical properties. The advantage of micro-EDM are complex shape or mold that would otherwise be difficult to produce with conventional cutting tools. Extremely hard material that can be machined to very close tolerance. Very tiny workpiece where conventional cutting tools may damage the part because of mechanical force. No direct contact between tool and workpiece. The disadvantage of micro-EDM are the slow material removal rate, the difficulty of sharp corners on the workpiece due to electrode wear, the occurrence of excessive electrode wear during machining, recast layer formed on the EDM surface, and further deterioration of its mechanical properties.